is a brief video talking about direction fields. They're very used in our text, so how do you do it by hand? We'll later see how to do them in MATLAB, but first let's look how to do it by hand. We're looking at the simplest case, in which is a first order ODE, in which the right hand side depends only on the solution and not on the time. So we want to solve for v such that v prime is equal to f of v. And we draw something. We draw a plane in which on the horizontal axis we have the time, and on the vertical axis we have v. So we want to be able to draw a function v of time, but we don't have it yet. Well, the only thing we have is the derivative of v with respect to itself. So we take one value of v, for v naught, and we compute the derivative. We can because we know the formula of the derivative, that is f of v naught. And this doesn't depend on time, so we can draw it everywhere with respect to time. This is a slope. So we're expecting the solution of our ODE to have this slope at this height. This value v naught corresponds to a slope of our function. And we can do this for a lot of values of v. Ideally, we want enough values for this thing to grow to be full, enough for us to draw a solution. So we take a starting point and we draw a possible solution that is tangent to all this loaf we just drew. This is what is called a direction field. It's giving us the direction in which our solution is going.